In this video, I'm going to explain how this proof works from a book called High Algebra by Hole and Knight. If you want to go check it out, this is on page 4. So basically, the proof is saying that if these fractions are all equal to each other, you can pick out any of them and they'll be equal to this big fraction down here. And P, N, Q, R are all random numbers, whatever you want. Okay, I wrote it out like this here. So I'm going to go through this very slowly because this proof is pretty cool and I want to explain it properly. So we're going to denote these fractions with one letter and we're going to call that K. So rid of this. All of these are called K. And that means we can write them like this. I'll tell you how in a second. The reason we could do this because let's say like C over D. We know it's equal to K. Just multiply both sides by D, you get C equals DK. Same for all the other fractions. Now, we know 100% this statement is true, right? Because we haven't really changed that much. Now, we know whatever we do to one side in algebra, as long as we do it to the other side, it's allowed. The equation will stay equal. So we can just go and do something kind of crazy like this. Now this looks like I've done a lot of things, but really I've only just added some extra letters to both sides. Okay, and because of the rules of algebra, we also know that this statement is 100% true. So we can trust this. This is kind of like a rule for us. So that means if we go back to the original kind of big thing that we're trying to prove, then technically we should just be able to substitute in, right, these values. And we should get K, which is what we're trying to prove, because K is equal to our fractions from earlier. So let's do that. Let's start substituting. Now, PA to the power N is the same as this here. So we can write it like that. Same with all the other ones here. And at the bottom, we can just keep it the same. Now you can probably see where we're going with this now. We can start cancelling things out because, of course, there's a bunch of common numbers here. Cancel, 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 cancel. And when you do all that simplifying, you're basically just left with K to power N over 1. And in brackets, to power of 1 over N. Of course, these cancel, so you're left with K. And remember, K is every fraction from before. So that's how we just proved it. I think this proof was really cool and I hope it made sense how I explained it.